Hi y'all. This is just a real quick explanation on the EPSILON problem solving strategy for identifying double values that are close but not exactly the same. So the general idea is this. Sometimes you're going to have a value. Maybe this is 1.379 and another value that you're calculating and you're expecting that they're going to be close to the same. And if you check to see if they are the same, if you check to see whether or not A is equal to B, sometimes if there's especially if there's a calculation involved, sometimes they won't match exactly. And so you'll have unexpected results. If you were expecting A and B to be the same and they're just a little bit off due to rounding, then this statement is not going to be true. So we have a strategy for checking to see if two numbers are close to each other. And what you do is at the beginning of your program, we'll look at a real program in just a moment, you say, you declare a variable, public static final, meaning the number's not going to change, double, and then you give a variable name, epsilon, use all caps to indicate that it's a final value that's not going to be changing. And then you give it a really small number, which is effectively your precision. This is 1 times 10 to the minus 10. That's a really, really small number. And Java accepts that. And what you do then is in your program, when you're ready to compare and see what's going on, you don't just check A and B. What you do is you check the difference between those two. So you would say instead, if the absolute value of A minus B is less than or equal to this epsilon, then you're close enough. You're saying the difference between these two numbers is so small, it's less than or equal to this here, so small that you're going to consider them good enough. And so then you can continue. You've effectively checked to see if those two values are the same. System out print line, good enough. Or whatever it is that you're going to be doing with those. It's okay to continue calculating with those. So let's see what that looks like in an actual program here. So I wrote a little epsilon demo here. We'll take a look and you can see what's going on. I've got that public static final epsilon. This should be a negative 10, a really small number. And here's our program here. And I'm just calculating very quickly a result here, 4.35 times 100. Now you know and I know that that should be 435. But when we print out the result, it actually comes out to be, I think, 434.999999, something like that. Something ridiculously close to 435. But the computer, if it's checking this, if we're checking to see if the result is equal to 435, it's going to say that we got the wrong answer. It's going to tell us that we got the wrong answer. We wanted 435. What else do I have in this program? Well, then I use the epsilon value. Again, here's this constant that I've declared, this final value epsilon, 1 times 10 to the minus 10. And we're going to check to see if those two values are close enough. If the result I got, minus 435, absolute value of that is less than that really small value, then we'll say you got the right rounded answer. You were only off by blah, blah, blah. Otherwise, we'll say you weren't even close to the right answer. So let's see what happens when we go ahead and run that and get a result. So it looks like it was, 434.999, or super small difference between those. And our first statement was, you got the wrong answer. We wanted 435. You got the right rounded answer. You were only off by. So apparently this was the rounding error. And you can see that that difference is less than the 1e to the minus 10 that I had before. So therefore, we're going to accept that small bit of imprecision and say, yeah, they were close enough. We're good on that. So yeah, it's a great tool for me as a teacher when I have to check to see if you've gotten the right answer for a double calculation. I use epsilon all the time, and you should know how to use it too. Hope that helps.